All right, here's your hint for this one. It is a long one. I'd also recommend watching the instructional video down in the description. So to start off with, the first thing you want to do is you want to start with your big circuit and get it down to a single total resistance. So this is what we've been doing up to this point. So we're going to look and we're going to combine some stuff. So I see R2 and R3 are in series. So I combine those together. I then see that into my case, I called it RA. I then see I have R1, RA, and R4 in parallel. Multiple paths between those two nodes, but only one resistor on each path. And I have those three in parallel, combine them in parallel to make a single resistor. Then I have RB, which is what I called it, and R5 in series, combine them to get my total resistance. Each time noting I use series, then I use parallel, and I use series. Because once I get to the end, I'm going to use the total voltage and the total resistance to find the total current. Okay. Now I need to work backwards. And so here, the series, okay, so that means I'm going to take that current that I just had through the total resistance is going to be the same as the current in both of these. I can then use Ohm's law and solve for those individual voltages. So the voltage across 5 would be the total current that I just brought back times R5. Same thing for RB. I can find the voltage in RB. Now, when I move back, I know RB was a parallel, so the voltage in RB is now going to be the voltage for each one of these. And so then, okay, I know the voltage across A is going to be the same as the voltage I had in B, is going to tell me the current in A using the resistance of A. Now that I know the current in A, I can go back one more step. Series has the same current, so I now know the current in R3, and if I know the current in R3, I can find the voltage drop. There's your hint.